Okay, so this is theorem 2. So what we're trying to prove with this one is that the sum of the lengths of any two sides of a triangle is greater than that of the third side. So basically if you take, so let's say this side and you add them up, they will be, the two of these added up together will be bigger than this side on its own. So what we can say is that if we take, for example, the line AC, we can write like this, so the line AC, and we add it, so the length of that line, if we add it to the length of the line AB, the two of them together, it's going to make, it's a bigger length than the length of CB on its own. So this is what we want to prove. This is what we want to prove. So we're basically trying to prove this. So if we were to take this length and add them together, it'll be bigger than this length. So the next part is, so we have like a little construction that we need to do. So construction. So basically what we want to do is we want to form another triangle that's attached onto this. So let's say what we can do is we can extend out from A, okay, but we want to extend out the distance from A to C, okay, so we want to make another point and we'll call it point D, but we want that point to be roughly equal in length to AC. Okay, so let's say, so that's roughly, okay, so it's roughly from here. Okay, so let me just maybe pull this down a bit. Okay. So we roughly want, so we want to create, so let's say, so it's roughly 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So many of those lines in it. So let's say 1, 2, 3, 4, 6, 7, 8, 9, 10. Okay, so it's roughly 10 units. So it's roughly 10 units. So we're going to extend out from A roughly around 10 units. So let's just go on that. So roughly around 10 units. So we're going, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's roughly there. And I'll just draw a line. Just draw a line from there to there. Okay, that doesn't look quite right. So let's change that. So we just change this around. Okay, so it's roughly, okay, let me just get rid of this. Okay, so you're talking about a point roughly out about here, and you want it so that this length here is going to be equal to that length. So maybe it might be just a bit further out about there. Okay, and we'll call this point D. And then what we want to do is we want to join up these points. So we can use our ruler to do that. Okay, 1 second, so keep this in here. So let's say roughly out to about we want to say roughly out to about let's say roughly about there. Okay, so I'd say roughly about there. And then we just rotate this around. And then we want to join C to D. Okay, so we'll just join these together like so. Okay, so roughly like that. And let me just clean this up a little bit. So just get rid of these guys. Oh. So just get rid of these. Okay, just here and here. Okay, so I will call this point D. So it's roughly about here. So what we're saying is that this side here, so this guy and this length are going to be equal to each other. So you're drawing a point out here and you're making this length and this length equal to each other. So let's go back here. So you want to, so you're, okay, so make a point D. So this is this point here. So D, maybe if I bring that in a bit closer, it might be easier. Let's get rid of that. So this is point D. And then basically what you're doing is you're extending BA out to D. So extend AB to, so extend AB to D. That's all that means. And then what we can say is that the line segment AD, okay, so the line AD will be equal to the line AC. And what we can say then as well is when we've created these, so basically we've created an isosceles triangle. So this length is equal to this length, so therefore this angle, okay, and this angle have to be equal to each other. So what are some of the things that we can prove by looking at this then? So what we can say is, so our proof, well, we can say that the angle ADC, so the angle ADC is equal to the angle ACD. I should put my angle sign in there. So the angle ACD. So we can say that, okay, so this angle here and this angle here are equal to each other because it's an isosceles triangle, and this length are equal to each other. And what else can we say from this? Well, we can say that the angle BCD, okay, so that angle BCD will include these two, this bit and this bit here. So we can say that the angle, so the angle BCD is going to be bigger than the angle ACD. Okay, so this angle here is going to be bigger than this angle here on its own. And then we can say as well that if, so for example, if the angle BCD, so if this angle is bigger than this angle, then it also has to be bigger than this angle as well, because this angle and this angle are equal to each other. So we can also say that. So the angle BCD is also going to be bigger than the angle ADC. So basically what it's saying is that this angle, so the angle in here, this bigger angle, it's bigger than this one, and it's also going to be bigger than this one as well, because these two are equal to each other. Now, what we can also say is that, so this here is the biggest, so this here is the longest. Let's say if we take the triangle BCD, then this length here is the biggest, this is the biggest side. Okay, so the side D to B is going to be the biggest side because it's opposite the biggest angle. So what we can say then is that if we take the side, so take this side, let's say, so the side B to D, okay, so the side B to D, so or the length, if you like, B to D, we can see that that's greater, it's bigger than this bottom length here. Okay, so B to D is bigger than here. Okay, so B to D is bigger than B to C, is bigger than C to B. Okay, so we can see that, so B to D is bigger than B to C, so we can see that from here. And what we can say then is, if we think about it, so what's another way that we could write B, the length B to D? Well, the length B to D is the same as the length B to A plus the length B to C, because all B to D is B to A plus this length here, D. But this length here, A to D, is equal to the length A to C. So that's another way. So another way that we could, so instead of saying B to D, we could also say, we could call it, for example, this length here, A to C. So A to C plus the length A to B. Plus the length A to B. And we can see that that is clearly, so if this length B to D is bigger than this length here, C to B, then it only stands to reason then that this side here added to this side here is also going to be bigger than C to B. So therefore, these two sides here are bigger than the side C to B. And this here, and this is basically what we've set out to prove. Okay, so we've set out to prove this. So that's what we've done here. Okay, so that's how you do it, and that's what we've ended up with here. So what are we saying? The sum of the lengths of any two sides. So if I add, so for example, this side plus this side is bigger than the length of the third side. So then this will be the length of the third side. So we can see that. So basically what have we done? So we started off with this triangle, we plot a point D, we extend out this line out to D so that the length of A to D is equal to the length of A to C. And then we join this back up. So what we get then is we get a bigger triangle, so BCA. Okay, this length here is the longest side because it's opposite the biggest angle. So remember, the angle BCD is bigger than this angle and this angle. So therefore this is the biggest angle in the triangle BCD. So therefore this is the biggest side. Another way, so we can clearly see that this big side, so B to D, is bigger than this side down here. And like, what is the side B to D? The side B to D is made up of the line segment B to A plus the line segment A to D. And another way that we could write this is just, so because this smaller piece is equal in length to this piece here, we can also write this as B to A plus A to C. So therefore we can prove then that so A to C, so this side here, plus A to B, which is this side here, has to be bigger than this side down here. So that's that one. So that's theorem 2, just proving that the sum of lengths of any two sides of a triangle is greater than that of the third side.